Well, my name is Philippe Rinaldi, and I work for ARM. I'm a principal software engineer at ARM. And I'm the tech lead of the safety critical machines team, which is a fairly new team, created a few months ago, which used to be the robotics team, actually. And so I'm going to present today a new project under this group, which is called the LibDDSSec. And it's a library that we are created to implement security, the security extensions of a DDS library using the OPT or AT environment. So I'm not assuming that everyone knows about DDS, so I'm going to have some slides just to explain what DDS is and how the security aspect of the DDS is implemented. I'm going to talk very quickly about the ROS project, which is it's the project that actually created this library that was based on that environment that we came up with this library. And then about the library itself, and finally why we are doing this work. So, excuse me. So the DDS stands for Data Distribution Service. It's a standard. There are quite a few implementations of this standard. There are many open source ones. There are some quite important commercial ones as well. And it's based on the publish and subscriber model. And the main idea is that applications can use this layer to do distributed applications. So they don't need to care much about the networking. And the main way that this library is used is exchange the data via what they call topics. And each node of the system can publish or subscribe to these topics. So there's a sequence of diagrams now to give more a better idea. So the blue cloud is the domain. So that's what's going to be on top of the network. And as part of that domain, you have the multiple nodes. The nodes could be just isolated computers or maybe applications. So you could have, for example, node A and C as part of one computer, and node B a completely different computer. And nodes can create the topics. A topic is a unique name on your domain, and it defines things like what's the data type is, and also there are some quality of service that you can relate to the topic. So in this example, node A is creating a topic, and in this example, nodes A and C are publishers of this topic, so they can send data, or which we call sample data. And node B, for example, is subscribing to it, so it can just receive this stream of data. Just to give a bit more details about it, so imagine that sensor 1 and 2 are two computers trying to just collect temperature in a system. It could be two isolated computers, or it could be sampling the same temperature, but it's just being used for redundancy. So DDS allows you to add some quality of service, which says always use sensor 1, or always use the data from sensor 1. But if sensor 1 goes down, then start to use sensor 2 automatically. Right, so it's a standard, but it's actually quite a lot of specifications to go through the DDS. There are three main ones that we are using for our work, and these are the Fast-RTPS, which is the very low level. That specification is going to specify exactly how the packets are moved on the network, so you can have actually multiple vendors of DDS still participate on the same domain. The DDS itself, which is the high-level specification, which takes care of the whole model and explains all the objects and how the interactions happen. And finally, there is the DDS Security, which was a specification that actually came after the DDS already existed. And that's why it explains all the detailed aspects of security and how the other specification needs to be changing its behavior to add the security layer to it. So for the security model, it's the spec specifies what the users, the objects, and which operations you can do on each of these users. And it has the basic security aspects to it. So you can do confidentiality where the messages passing between the nodes can be encrypted, so you can protect from eavesdrop. Integrity, so you know that it's not corrupted. You have authentication for the reads and writes, so you can say a given node that's trying to do a read and write if whether that node is allowed to join the domain. There is authorization, so if you have a node that is allowed to join the domain, you still might restrict what it can do. So it might still can just publish specific information, specific topics, or it might just be able to read some of the topics. And then message data origin, which means you know where it's coming from, and non-repudiation of the data as well. So you know you cannot deny sending or receiving some of the data. The spec has quite a nice long chapter about the threat model. And there are 4 main groups of attacks that it describes quite in detail. So it's the unauthorization of subscription. So you know, so it specifies how to protect against someone trying to subscribe to a topic that it's not supposed to be allowed to. And the other way around as well. It explains how it protects from nodes trying to publish to topics that they are not allowed to, tampering, replay, and also unauthorized access to data. So then going closer to the implementation, this is where we are getting more involved now. The spec actually splits all these dynamics of the security into 5 what they call plugins, but there are 3 of them that we really care more about at this point, which is the authentication, which deals with everything related to the certificates and key management on the system. There is another plugin, which is the cryptography, and all the encryption, decryption, all the aspects of it is dealt into that plugin. And the access control, which is the one that put everything together and enforces the policy of how these are all used. So there are quite a few different algorithms used, but the spec, it restricts at some extent what can be used, but it still allows you some flexibility to choose, for example, key size and other aspects. So asymmetric keys are mainly used for the discovery phase and authentication because it's a bit more compute intensive. And during the normal operation, it's mainly used in shared secrets between the nodes. So the security can be configured at the topic level. So you can have actually topics that are completely unsecured, that just open. Any node can attach to the system and read and write the topics. Or you can have specific topics being protected. And even you can have different levels of protections on different topics. So you might say a given topic is going to use a key size, 128 bits or 256 bits for different ones. Well, like I said, I was going to talk a little bit about the ROS project because that's where this library was born from. So the ROS project is it's a robotic framework, actually. It's not really an operating system. And it's a bunch of libraries and tools that can be used to create robots. And it's quite interesting because the project has also a huge library of packages, which are mainly open source, where people just contribute to it. And the idea is that it's quite easy or simple to get started on your robot because you can reuse lots of these packages and just focus on what you're trying to develop. And so for the version 2 of the ROS, they moved from a custom implementation for the multi-nodes to use DDS. So you can see on the diagram where DDS is the low-level layer to do the communication. And on top you have what is the ROS really, which is the middleware, and a few different interface. So you can develop the robot nodes or applications using either C++, Python, and C. There are a few other contributions to do different languages, but those are the main three interface. So when you download the ROS project, it comes with a open source DDS implementation that's from eProsima. It's called Fast-RTPS. But there are still other implementations. For example, the RTI, which I mentioned on the slide, that's a commercial library, which also you can just swap them if you have the license or any specific needs. So that's more or less an example of how a hypothetical robot would be created. So you have, for example, the blue boxes are the packages or the applications. So in this diagram, it's split into two systems. So the robot itself, where you have, for example, it could be a wireless joystick, which is publishing coordinates to a topic joystick. And in this case, the motion package is actually subscribed to those inputs. And then it does all the movement of the robot based on the position of the robot, and it can output what's the speed and what's the direction that the robot is going. You might have, for example, then also feeding a camera, which is a LiDAR, just detecting the depth of the environment, and all that information can be put together. Again, another module, which is completely standalone from the other ones, and that generates just a map in another topic. And you could have off the robot a visualization of that map. And the idea is that you can play with this module. So, for example, if someone's trying to develop some kind of autonomous robot, they could simply drop the joystick module and create their own planning, which then is going to, based on the map and the position, to feedback what's the next movement that the robot should take. And the interesting thing about this is that you can do that off robot. So that could be just a development machine, a desktop machine. And because the DDS allows you to dynamically enter and exit the domain, the development cycle is quite interesting. You can just kill that, do the development, and spin up again and try it, for example. So that's the ROS project. I'm going to talk about it a little bit more at the end. So the library itself. The main goal for the library is actually to move everything related to security into the T. And that means all the certificates, all the key that are generated during runtime to do the peer-to-peer communication. And also, of course, the security operations, all the encryption, etc. One of the reasons, of course, is to limit the surface attacks. There are still some problems around that, but one of the main goals is really to avoid, for example, leaking the keys. The third point is kind of the main or the initial requirement for this, which was to have a reference code on how to use TrustZone to secure DDS or to secure a robot where the project was born. So that's an overview of which shows mainly how the current implementations look like. So, and this is it's specific, this diagram is specific to the Fast-RTPS, but it applies to other implementations that you can find out there. So the DDS implementation has its own plugins inside, and these plugins usually just use an external library, which in this example is the OpenSSL. Everything is the user space, so you have the certificates which just lay on the file system, and all the operations are in the non-secure world. So the first attempt to use the T for this environment was to actually get rid of the OpenSSL at some extent, or intercept everything that used to go into the OpenSSL into this generic API. Now, the initial version of this API was very similar to the OpenSSL. It's pretty much just retargeting this generic API, so you can actually retarget that to the T. backend, which is going to use then the OPT, and all the security operations now are under this trusted application. But of course, this was just a proof of concept, because if you see, it's still all inside the DDS implementation. And so when this project was created, that was when I joined. So we discussed, and that's the proposal, and that's what we are working on now, right now. So we split this out, so now it is a proper library, which is being developed. So that allows us to reuse these or to target the multiple DDS implementations, even open source or commercial ones. By the way, so this version, even though it was using OPT for many of the operations, it was still relying on the OpenSSL at the same time to do some of the operations. So all the certificates are still under the OpenSSL. That's why we still have this arrow here. So that now we are working on that right now. And the goal is that we have just a pure API to expose all the security aspects to implement for DDS. And then we have different backends. We are working on an OpenSSL backend, but that's mainly for validation. So we can, because we are getting rid of the OpenSSL there, but we still have it there. And we are moving, you can see that trust application is growing because we are moving pretty much everything into the TA right now. But there's still a problem with this topology, which is these green arrows. They are still very specific to one implementation. There is a chance that the library don't expose enough APIs for a different implementation. So what we are still discussing at this moment is doing something like that, which is to move all the plugins actually into the library, because the DDS specification does have some level of description on how these plugins needs to look like. It doesn't give you the exact API, but it does give you which kind of attributes, etc. it should have, or which kinds of operation it should do. It should expose. So this is more likely what we are going to have going ahead, actually. But we discussed with some different DDS vendors at the moment. What else? So yeah, current work is we are moving from that prototype, which had all the components inside the DDS, into the library. So that's the main bulk of the work right now. Because as part of that process, we are also reviewing that API. If you see here, that this API, which was based on the OpenSSL, it still have quite a lot of functions that, for example, pass the keys and input the keys, but now the keys are going to be all in that TA. So there is a bit of review and refactor on that area, which is happening on this work. The prototype also relies quite a lot on the DDS implementation to validate itself. And so we added a Unity or a test framework, and we are adding quite a lot of tests as part of this process. I have no idea what I was right there, to be honest. Just left a broken phrase. There is, maybe that's one of the priority of the project, which is to create a threat model to ensure that the prototype or the design is really sound. And there is still quite a lot to discuss in terms of key deployment, because that's going to be one of the weak links on the whole system. And there is still, as much as we are moving the whole security assets into the TE, there is still the problem where if the non-secure side is compromised, someone could still pretend to be a real application and try to use the secure assets which are inside the TE. That means we are not leaking the keys, but that still means that someone could pretend to be who they are not. Another important work that still is ongoing is to use the new OPT, which was released recently and has a support for the certificates. So we can really move everything into the TE environment. The main challenge Probably latency is going to be one of the main problems to be solved, or one of the main trade-offs of doing it this way, because there is now the extra step of going to the TE and doing everything in that environment. Of course, that could be perhaps improved if there is accelerators attached to the secure side. There is a company which recently released a benchmark tool, and we are planning to use that tool for some of these investigations, actually. Yeah, so I mentioned about that one. There might be vulnerabilities on the if there are vulnerabilities on the non-secure side that could exploit some of the designs. And finally, the key and certificate deployment needs to be properly defined, because for most of the DDS implementations, that is just bundling certificates and configuration files into the non-secure side, where if we move everything to the secure world or into that TE, that means we need some mechanism to do that during the deployment of the application. There are a few things we could do in the future. That's, I think one of the main ones is trying to use the hardware ID to derive the keys. So you can really say a given application or a given system is who they are, because the keys are derived from the hardware. As far as we are aware, OPT doesn't have that support yet, or even the global platforms don't have any APIs to do that in a generic way. And another possibility we should be able to evaluate is eventually actually move the whole application, the whole node, into the TE. Of course, that would mean quite a lot of complexity, because the DDS would have to be split between part of it running the TE and part of it still on the non-secure to deal with the whole network aspect. Just some details about the project. It's going to be released as soon as we can. Let's see when that's going to be, but it's going to be under the ARM software umbrella in GitHub. Planned license is going to be BSD, but until it's out there, let's see. The library is mainly being written in C, but if we do move the plugins into the library, that's going to be probably a C++ interface, because that's what most of the, if not all the DDS implementations actually use, which makes more sense. We are using for development the ARM platforms bundle, which is, and in the ARM platform we use more specifically the base model, so it should be quite easy for someone to just get that binary stack and get the library and try it out. We still have to do some change, but we are trying to liaise with the other teams, because OPT right now is not enabled by default, but that's something we should be able to sort out. When you get the ARM platforms in the future, we should be able to get OPT everything enabled by default. And finally, why we are doing this. The second point is the main one, actually. So we are looking to more specifically on the automotive side for this work. And DDS has been adopted in quite a few different projects. AutoSAR recently announced that they have been adopting DDS as part of the adaptive specifications. Baidu's Apollo also, they used to use ROS1, which is not DDS-based, but they are moving away and create their own solution, which is on top of DDS as well. And Outware, which is another open source project, it's using ROS1, but I think it's planning to be using ROS2 soon, right? And someone in this room is going to be working on that, as far as I know. We do know other frameworks that also use ROS2 from other companies, and we believe that there are maybe many more that we don't know about. So that's the main rationale for doing this. And that's it. I think it was just in time.
Yeah. One quick question.
Yes.
Is there a plan to support? Is it on?
It isn't.
Okay. Is there a plan to support other ARM architecture? So currently you have support for V8A
Yeah.
architecture.
Yeah, there is no plan, but there is the intention to allow it to happen. So for example, that's why we have also these backend topology. I'm assuming you think about TFM, right, or something like that. Yeah, so we did think about that, which would be, we should be able to have another backend and somehow to port a TA to also run on top of TFM, hopefully.
Okay.
Yeah. All right.